If you don't have a data analysis, you can go to options, file options, add ins, and cell add in, go, and then keep going.
Add-ins. Go. And then you click the tool and the tool pack. Yeah. Okay. Just the first one. Yeah. Yeah. Okay. So if you go to data now, and yeah, you can see that.
Okay. Okay. Data regression. Okay. Okay. All right. All right.
Regression.
All good. Okay. Let's go. And then you have to tell Excel which column is the y variable. The one single column is the y range, right? So for us, it's the yellow one. So it's from B9 to the last row. From B9 to B403. Alright? Yeah. That's my y variable or dependent. It has to be just one column. If you choose if you choose two or more columns, you get error later. Okay. Now my x range can be one column or more than one column. My x range. Click on the arrow here. Now you can choose the x. So I'm going to include all the other columns after the yellow column. Right? So I'm going to include the column C, D, E, F, G, whatever, all the way down to the last column.
So for our assessment 2, is it all of them as well?
Yeah, I will tell you later. Yeah. So let's choose all the other columns after the dependent variable. Control Shift now. Alright, go back. So it's a C9 to P403. Alright. So basically C, column C all the way down to column P. Okay? Yeah. Alright. Now because my first row is labels, you see? Row 9 is a label, so variable names. So I'm going to tag cell. I'm going to tag cell, okay? Labels in the first row. Alright? So that the Excel know that the row 9, they are not data points, they are label names. Variable names. Okay? Alright. And then basically you can choose this one. So this is a basic option. If you want the more outputs, I can also choose residues and also normal probability plots. Okay, click OK. I got a new spreadsheet. Oh, that's spreadsheet number 1, number 2. Number 1 is data, number 2 is my output. So in the output, you see 3 tables. Regression stats, ANOVA, and the regression coefficients table. These are the basic outputs, right? So in the regression stats, it tells you the model fit statistics. The measure of the model's fit to your data, right? It has R square, multiple R, adjusted R square, number of observation, and the standard error. Standard error is kind of a standard deviation of the resolution. Alright? So my model's R square is only 20%. That means only 20% of variation in the yellow column can be explained by the green columns. So my model fit is not very good, to be honest.
Where is that 20? R square?
R square, yeah. Very, not very good model fit. But it's still statistically significant. My p-value of the ANOVA is very small. Yeah. So I can still say that in the population there is some relationship between the y variable and the x variables. At least some of the x variables, if not all, right? Yeah. So the R square is not zero. It's larger than zero. Right? And these are my best fit models coefficients. Best fit to my sample data. Right? So to my sample data in sheet number 1, that's the best fit model. That's the intercept with the slopes. Now we cannot visualize anymore because it's more than 3 dimensional. Right? I have a y variable and then multiple x variables. Right? If one x, one y is a 2-dimensional, if one y, 2 axis is a 3-dimensional. Now I have a one y and a bunch of x's is a hyperdimensional. We cannot visualize it, right? But again, it's a hyperdimensional sheet or plane. Okay? And those are the slopes of the variable. If you want to guess about populations model fit, you should look at adjusted R square and confidence interval and p-values of the coefficients. Adjusted R square is 17 or 18%. So based on my sample R square, I guess in the population, the model's fit will be about 17.8%. Okay, you can think about adjusted R square as a better estimate of the population R square, right? Because R square tend to overestimate population R square. And also, I can guess about the population models intercept and the slope by looking at the confidence interval. So you can see there's a bug here, right? This confidence interval is reported twice. The reason is here. So when you remember here, when you choose confidence level, if you don't choose, the default is 95%, and then it will be reported twice. It's a bug. But if you choose, for example, if you choose 99% here, 99%. If you choose 99%, then let's do it. If I choose 99%, okay. I will report 95% confidence interval and 99% confidence interval. I think that's good. Okay, fine. What? Oh, sorry. I need to go to the original sheet, data sheet. And then here, and then choose 99%. You see? So now they report 95% confidence interval and then 99%. But when you don't choose any extra ones, they report 95 confidence interval 2 times, which is a little bug of the software. I guess Microsoft doesn't want to fix it. There are some bugs in Excel. There are some bugs. And also you have to remember, when we are using the data analysis toolpack regression function, you can only use maximum 16 X variables. Yeah.
For Excel.
Yeah, for Excel. Model has no limitation, but for Excel computation limit, through this menu, the maximum number of X variables in the X range is 16. It may change in future, I don't know. And they have to be 16 columns next to each other, one by one. No gaps, no letters, nothing, just 16 columns. 16 columns of numbers. What if you have more than 16 variables? You can still do it yourself, but not this way. Have these other approaches. One is called a LinNext function. LINEST function. That can handle maximum 64 X variables. If you have even more than 64 X variables, it's also possible that you have to manually do the matrix inversion using matrix algebra, or partition of matrix inversion, which is a complicated. You should consider using some other software. Use Excel is not good for that. Alright, so for teaching purpose this is enough, but for practical purpose this is not. So this is the data analysis toolpack. The function name I mentioned, if you are interested, you can Google this one. Right? It's for the equal sign. LINEST function. Line. I don't know how to pronounce it. LINEST or LINEST. This function is also reporting. It's also doing multiple linear regression. Yeah, but the reporting is not a nice interface, and then it can handle the good thing is it can handle up to 64 X variables. Okay. Line. Maybe that's for LinNext. Okay. Alright, haven't finished yet. Remember I request the residues? That is the residues. So because I request residues, Excel, for each row in my data, Excel calculated the predicted value of y using my model, and then calculate the difference between the prediction and the observation. So this negative 0.26 will come from this one, 0.15 minus 0.41. Right? So Excel did the calculation for me, the predictions, and also calculate the residues for me. Right? So if I want to have a check of the distribution shape of my residues, I can just highlight these values here, and then go to put a histogram. This is the histogram of my raw residues. Right? Does it look normal? Well, at least it's symmetrical. It's kind of bell shape. As it's fine, right? And also remember, also check this one. I also check the normal probability plots. Remember that? Yeah. So Excel That's why I have these two more columns here. Over here. The quantiles. The observed quantiles and then predicted quantiles. Right? And then Excel show me a plot which is over here.
Oh yeah. Go to this one. Yeah.
So this normal probability plot is just a scatter plot of these two columns.
How did you do it? I
Huh?
didn't see.
Because I request this one,
Yeah.
normal probability plot.
Uh-huh.
So this plot and these two columns come from that check. If you check that box, you get this. Yeah. This one. Yeah. If you don't check anything, you only get the three tables here. You only get these three tables. Okay, really? Oh, sorry.
Yeah, I did.
1, 2, 3 tables. Because I checked the
Yeah.
residues, I got this table. And because I checked the normal probability plots, I got this table and this plot. So these two. Right? That two.
You changed the style of the.
Huh? I didn't check, I
Did
just
you
checked it. I checked it from the first place.
I mean,
You didn't see it, yeah.
did you change the style of the probability plot just now?
No, I
or?
didn't change anything.
Oh, it was already
I
there.
just
Okay.
moved it from the top to
You
here.
moved it from. Okay, got it.
Yeah.
This one, small.
Yes, I think that's one. He just
Drag
made
it.
it
Yeah,
bigger.
I just drag
made
it
it
over.
bigger.
I make it bigger.
Bigger,
Yeah.
so
Make
that
it
why
bigger.
it looks.
It's a scatter plot. This is a normal quantile plot. So the purpose of this plot is to check if the residue can be followed, can be assumed to follow normal distribution. Yeah, so we want to see a straight line. A straight line means the distribution of the data is very close to the normal distribution.
What if it's below this?
Huh? No, it's good. It's a straight line. It's fine.
It's my assignment. Just plain.
Oh yeah. Doesn't matter. What we care about is the shape.
Yeah.
We don't care about
Shape
this
or
slopey or down or whatever. What we care is the shape. If it's a curve, that means the distribution of the residue is not normal. It's some other shape. Maybe skewed, maybe like two peaks or something, or flat. For this QQ plot or quantile plot, normally we just care about the shape. If it's a straight line. If it's a straight line, that means the observed data is following some theoretical distribution. And then the distribution we are trying to check is normal distribution. We compare the observed quantiles, percentiles, against the theoretical normal percentiles. If the shape is the same, then you should see a straight line. Okay? Alright, I'll show you one more thing. Remember, we can check the pairwise correlation among the variables. It's very simple. You go to a data sheet again, and then go to data analysis, and then choose correlation coefficient. Oh, here, correlation. Don't choose covariance, right? Choose correlation. You choose a correlation, And then you go to your input range, you choose all the variables. All the variables. All the columns.
Including Y, the yellow one?
Yeah, you can. Yeah. Okay. And then again tell them labels in the first row of your section. So row 9 is not data, row 9 is labels. Row 9 is labels. And then choose OK. Excel will calculate this matrix for you. Right? If you don't include the future, if you don't include the yellow column, then you will not have the first column. Right. Again, for checking the collinearity, what we are interested in is the correlation among the x variables. You can ignore the first line. But you may also want to include the y variable in there, because at the end of the day, what we are interested in is the relationship between the y and each of the x's, right? So when you are describing your data, I just include everything in there. Right? So good? This is easy, right? Now, okay, if you think, oh, it's too many data, I can't check. So first of all, I'm going to remove the redundant number of decimals. Alright? Remember this little button? This little button in the home? Highlight the numbers and go to home. These two little buttons. Choose the numbers. Alright? And this home button and this one, you can make more or less decimals. So rather than 10 decimals, just show me maybe 3 is enough, or 2. Half the decimal point, 2 digits. That's enough. Right? That's much better than this one. Right? Looks scary. Right? Look stressed. Right? So just 2 decimals, or maybe 1. Okay? Not maybe 2. Right? And you can also go to conditional formatting and highlight values using some color scales. Right? There are many options here. Right? You can highlight some top 10 or bottom whatever. Right? Yeah, it's all in there. Highlight the data and do conditional formatting. Right? You can highlight. You can add some color scale or highlight the top 10 or top 10% and the bottom 10 or bottom 10%, or highlight a value below 2 or above 2. Okay, I just use a color scale. I'm lazy. It's color scales. So there's some color scales that are built in Excel. So red means very negative, green means very positive, and the yellow means something. So here you can see, of course, the diagonal will be green, because they are the 1, 1, 1, 1. So I just want to know some green ones and the red ones. So they're not too bad, right? So the smallest one is only negative 0.3 to 0.2. The highest green one is only, this one's good. Right? Also this one. Okay. So this is a quick visual check.
Easy to identify.
Huh?
Easy to identify.
Yeah, it's because we are more sensitive to colors than numbers, right? If you're not colorblind, right? So I shouldn't make that comment. But anyway, so we are more sensitive to colors than numbers, so it's just easier for us to draw. All right. Now, if you want to predict the future variable, okay, if you're happy with the model, okay, and then how to predict my future day, Remember we have a testing day here. We have the x variables here, and I want you to predict the future price and compare with the real future price change. It's very easy because your model is here. Model is here, right? Just highlight this. Copy. And then come to your data. And then below here, you choose, okay, how much? Okay. Then these are coefficients, right? Copy. And then come to your data. Below the yellow cell, you choose case special, and then you choose case special, choose transpose. So that will transform the column into a row. Right? Right? Yeah. Am I right? Yeah. Okay, and then we can predict. We have to insert a new row. Yes. Okay, sorry, no. This one. Insert a new row. So basically, I just copy the column of coefficients and then paste into the row below the variables. Right? And this one is my intercept. So basically, my prediction will be my intercept plus this times this, plus this times this, plus this times this. Right? Remember? Y is equal to beta 0 plus beta 1 times 1, beta 2 times 2, beta 2, all the way down. So my prediction of my future change of my testing day will be equal to my intercept plus sum product. The green cell of x variables with the new row of the coefficients. That's my prediction. So just the intercept E7 plus the sum product of the x values in the row, comma, and the coefficients. And just copy paste. My prediction is positive 0.52. Which is not too bad. At least I predicted right direction. The real change is at 0.177. My model's prediction of that day is 0.52. So it's not too bad, but it's not too good either. At least it's in the same direction. I didn't predict negative, right? My model didn't predict price drop. So that's not too bad. Okay. That's using the Excel basic functions. And remember, in week 1, did I do it or not? I told that in the assignment 2, we can use a different tool called the PHstat. PHstat. Have you installed it already? PHstat. All right, I'll show you. So if you are using Windows, then it's easy, right? If you are using MacBook, it could be a headache. Yeah. Even some Windows laptops doesn't allow you to install either.
Yeah, I tried to my one. That wasn't enough.
It depends on the setting. Alright, so in our tutorial files, we have this one, you see? phstat Windows, phstat MacBook. So if you are using Windows, you can download this one, phstat Windows. Download the file. Okay. So it's called phstat 4.0 copy. And then it's a zip folder. So I have to first of all unzip it. Or extract all. Okay, this is zip, this is extracting. Extract all and then go to your Excel and go to File, Options, Add-ins. And click Go. Right? And then you go to choose Browse. Just browse this time, right? Get an error message, just ignore, click OK. And then go to the folder you just extracted. For me, it's this folder. So try to browse to the folder you just extracted. And then go right away down to the last layer. And then choose the phstat file. It's an add-in file, right? You see here. It's an Excel add-in file. And then click OK. Yes. Alright, and then check this one, phstat. Check it. And then click OK. Now, if everything goes well, you will see this phstat menu here. After the help menu, beyond the help menu, you will see the new menu called phstat. And then we are going to use the multiple regression function. Okay? You get it?
Is it mandatory to use that one?
Yeah.
Is it mandatory to use PSStat?
Yeah, this is phstat. We need to use a regression, this one, multiple regression function. That's a phstat. Okay? Alright. I'll show you how to use it. Very simple, right? So you have your phstat installed properly. You may not be able to install it depending on the machine you're using. Right? So if I have installed, you go to regression, multiple regression. And again, our y variable is just a yellow column, including the first row as variable name. Okay. And my x columns will be just the other row, other columns. Alright. Okay. Yeah, first cells in both range are variable labels. Yes, yes. And then you choose regression statistics table, that is R square, multiple R, adjusted R, this kind of stuff. And you choose the ANOVA and the coefficient table. And then you choose the residue table. And then don't choose the residue plots because that will create many plots. I don't need that. Right. And then just choose the DW statistic. Okay, and then choose the VIF, and then the confidence interval. You choose 95%. So these things are not available in your basic stats Excel function menu. And the VAF, EW statistic, the VAF, and also this confidence interval of estimate and prediction. So these are not available in your basic things. So if you want to include these ones in your report, you have to use the each step.
If you didn't support in my PC.
Yeah. the example use that. Yeah. All right. I gotta note down in a photo or something like this. Okay. So don't choose this one. This one will give you lots of loss. Yeah, not really. And also this one will also not really. And you choose the others, right? And then this one you can just choose 95%. Right? All right. And click OK.
But my PC doesn't have this one.
Click OK.
PC doesn't have it.
Give it some time because they will create lots of things behind
I
that.
don't know how to do it. When this one is not available.
Perfect. So now you have your data here and you have a computation. This returns the regression stats, ANOVA table, and coefficients. This is the residue here. Same as the one we saw in the basic output, right? There's a prediction here, and this is the residue. And then we have a bunch of, this one is a Derby-Watson statistic. So in this case, the Derby-Watson stat is around 2, which is good, which means we don't have an obvious multicollinearity. Right? Okay. Anything else? This MR data, don't worry about that, it's the middle steps. Okay, and then you have for each x variable, you have a VIF value. Okay. So we have some large VIF here, right? So like this one is 4 something. It's pretty large. This one also about 4, right? Also about 4 here. So we have some large VIF here, right? Also about 4. And the last one, the last worksheet is about the prediction intervals. So again, you have to copy your data of the day you want to predict into here. Right? So you go to your data set in my sheet number 1 over here. Right? So the day I'm trying to predict is over here, the first day. I copy the data, the blue data, right? I copy the data that I want to predict, the blue data, the x values. Copy them and then go to the last sheet, PICIE, and then go to this cell. Okay? I copy and paste special. How come you don't have to paste special? Let me copy again. Copy, and we go to the last worksheet. Paste special, transpose. Right. So I copy the row into a column. Now at the bottom, Excel will return the prediction and the intervals. Right? So the prediction is as I used it before, the same. It's predicted to be 5.226. Right? Just as I did before manually using the basic.
The same.
same thing. But it also predict the intervals, the confidence interval and the prediction interval, right? The confidence interval is to predict the average of the y given the x's. Prediction interval is to predict the individual y, right? So on average, for the day of those x values, is between here and there. For individual day, it can be anywhere between -0 to 1.05, right? So those are the confidence intervals and the prediction of the conditional mean.
Why would it the predicted y hat is minus 0.
It could be anything. It can be anything. It can be anything. Yeah.
So what is it saying? What's that?
And that's just the model's prediction of the
What is
dependent variable given the x variables.
anything like
It can be any,
over-
it can be anything. Of course, the closer the better, but
closer
we
the
can't
better.
control that. Yeah.
So it's like -1 to
Now for this one,
Positive
the
one.
prediction is 0.522. Right?
is there any range?
No range.
Oh.
No range. No range.
Oh, okay.
No range because it's a linear model. The real the observed y on that day is here. It's 0.177. My prediction, and also using the model's prediction using all the x variables is 0.522, which is also here. But using the pH stat, you can also calculate an interval around it. Like confidence interval, remember confidence interval? It gives you an interval estimate on top of a point estimate. So I'm 95% confident that if the x is this, and on average the y will be somewhere between here and there. For individual day, it can be anywhere between here and here. Yeah. So the model doesn't really perform well in predicting that day, right? Because it's out of the 95% confidence interval of the mean. But anyway, we can be very confident to say that when you see those x variables, we can predict the price will increase the day on the days, right? Because the outcome, no matter confidence interval or prediction interval of individuals, they are all on the positive side. Right? I wouldn't predict the price to drop. Right? So I'm very confident to see that. On that day, if I don't know price change, I can predict the price will increase. At least. But I don't know interest rate how much. but I know it will increase. Yeah. I wouldn't choose that. I wouldn't choose to predict the price will drop because it's all positive. Right? So definitely the price will I predict it to be changed to increase. Right? It's all on the positive side. All above 0. That's how to. But in your assignment too, you just have to work on your data you chose at the beginning, and then do this regression. But I want you to compare, not at least two or three models, right? So not just this one model. I want you to have a look at the VIF. See which one has the largest VIF. That means that's the most redundant variable given the others, right? And then try drop that variable from the data, and then estimate a new model, and then compare the second model with the first model in terms of the adjusted R-square and the prediction of performance. Right? I want you to try 2 or three different models. Yeah. So when you are comparing models, compare the adjusted R-square, right? Because the R-square will always be smaller for the smaller model. Try to compare the adjusted R-square. And then we are using the VIF as a guideline. So we always remove the most redundant variable, the one with the largest VIF. That's what we choose to remove. Right. Now, how to remove it is very tricky, right? For example, this one is X14. The VIF is probably the largest one. Maybe, I'm not sure. That means the 14th column is the largest redundant variable. Okay, so I'm going to come here. I would suggest you to make a copy of your data, right? Make a copy of your data, a few copies before you try the model. Alright. So then you don't confuse yourself, because every time you get lots of sheets. So that's my copy of my data. So for example, I found that in my first model, I found that X14 is the most redundant, okay? Because it's a VIF is the largest. I go to my data, and then column X14 means the 14th blue column. So it's the column C is X1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Column P is X14. So copper val 10 times aluminum val 8. You can double check this one. Double check the name. Right? Copper val 10 times aluminum. So that means this variable is redundant. That means you can just delete this column. Just ignore. Just assume it doesn't exist. Right? If it's some column in the middle, it doesn't matter. You can also just delete the column. Right? And then go through everything again. Y column, X columns, and then choose the things. Just remember, don't choose this one and this one, because they are kind of useless. And then get a new output, and then compare the new models with the second model with the first model in terms of the R square, adjusted R square, and all the other summary statistics. Alright? Yeah. And the predictions, confidence interval, and whatever. Yeah.
Sorry, could you please say again what is to try?
Just the first model is all the variables, using all the variables.
Yeah.
And see which one has the largest VIF.
Yeah.
And in the second model, try a new model with the
delete one or two.
Yeah, delete one. Just make small change every time. So the
One?
second, yeah, one
You can
every
do
time.
more than one.
You can, but you don't want to make too big change. A small change, because every time you change something, the other things change.
Yes.
So after getting this first model, check the VIF of all the X variables, and then choose the one that has the largest VIF. So in the second model, you're going to delete the X variable with the largest VIF in the first model. Okay?
I mean, the new model name would be?
You can name whatever you like. Model 1, Model 2, or Model A, Model B.
Do the same thing.
Same thing, just
call
with
it,
a
just
different.
model 1 to R.
Yeah, just different
I thought
columns.
that we would try different model. Different thing.
And do we explain this in our report? Like what are the changes?
Yeah, yes. You try to explain them. Try to you can try more if you like. See if you can find the best model. The one with the highest adjusted R square or best performance in the prediction. You can try 3 or 4 or 10 models. We have so many variables. We have how many variables? 14 variables? Lots of combinations.
We don't want to do that much.
Huh?
We'll try with one or two.
Yeah.
Or two.
But at least 2, right? If you just report one model, if you won't get good marks. Because in practice, you'll never just try one model. It's like searching. See which combination can give you the best.
So the big when we delete highest number of VIF, X a column,
Yeah.
then it's going to be changed the whole model.
Yeah, everything will change. Everything else
changed.
will be changed as well.
So we try 2, 3, 4, and then we are happy until we are happy enough, good enough.
Because every time you change one thing, all the other things also change. So I don't recommend you to change a lot. You change little by little. So every time you choose the model, you choose the one that has the largest VF, that's the most redundant. The most redundant X variables given the other X variables. But it's a bit complicated sometimes. You try a 2 or 3 or 5, 2 or 3 or 4, that's enough. So yeah, get all the analysis ready, and then next time when I meet you, we can talk about the report writing. Right? We can talk about report writing. Yeah. So you can this week, next week, make sure you get the analysis ready. We can write the report later. The report writing is not complicated. Just have to report me the problem, the data, the variables.
Yeah, that one on. Yeah. Yes, that one is. Yeah, and then 95.
What's your case study? What are the variables, their mean and standard deviations, and then their correlation matrix? The one we did before using this.
This is your data. Yeah, that's what I tried. That's what works. Yeah, it's similar.
That's the description of the data. And then you report the regression models. You can, for example, we have 3 models. Report. You can compare model 1, 2, 3, 4 in one table. Right? Or you can use 2 or 3 tables to compare the 3 models.
2 or 3 tables?
Yeah. We'll talk about writing later. So the writing is not hard. This time once you get the results, the writing is just straightforward.
Are you going to send us the best example? Because what's there, it looks
I can't
like
send the best. I can't send you the best. Otherwise, you just copy me. I give you some hints, but
okay.
yeah, that example is just okay, like a 70%, like a credit level. Yeah, or maybe less than that, because they only tried one model, right? A bit lazy and also very terrible writing in the format. Yeah. So try like for those 3 models. Okay, more or less 3 models.
So how to make this a lot of?
You don't have to report everything. You just report some important things. Yeah. So in data description, you report the mean, the variance, the correlation. In the model outputs, you compare the X variables you used, the R squared, the adjust R squared, and then you compare the VIFs, the p values, and then you compare the and then you compare the prediction, the y hat, and the intervals. That's it. And then you comment on the best models. You must have a best model out of your 4 or 5 models or 10 models. And comment on your best models, distribution, shape of the residue, QQ plot. Okay, and then that's it.
Yeah.
Very simple. Yeah. Our 5 perfect time. So next week, tell your buddy. I probably forget. So next week we have no time, but you can email me. All right. We will meet you in 2 weeks, which is week 8. Today week 6. Week 7 you work on your data. Week 8 we meet at 1 again, and then we finish at 3. Okay. So week 8 in 2 weeks. Week 8 we have normal time, and then in week 9 we have